Hello, everyone. My name is Apoorva Kulkarni. I'm a principal specialist SA for containers at AWS. I spend a lot of my time working with AWS customers who are building large scale AI/ML platforms, data platforms on Kubernetes with EKS. And I'm here to talk about how EKS Auto Mode can help you run your Ray applications with EKS. And today I'm particularly focused on Ray Serve, and I have a demo later on that shows how you can run Ray Serve in a very streamlined way with EKS Auto Mode. And so it's been what, like 10 plus years since Kubernetes has been around. And there's been an awesome set of tools and plugins and partners and vendors that have been created that help customers run a variety of Kubernetes workloads, right? And so we're seeing the same kind of tooling that the AI ML community has built over time. We see things like PyTorch, scikit-learn, XGBoost, and since November of 2022 with OpenAI, we've seen an explosion in terms of the tools that have been created for running large language models with open source tooling. And so what has happened is these two communities coming together to help run these large-scale machine learning workloads on top of Kubernetes. So there's been, Kubeflow has been around for a while. Kubeflow has been traditionally used with Kubernetes for a long time, but since then we've seen frameworks like Ray with VLLM, LLMD, AI Bricks, and all these awesome frameworks come out. And in the Kubernetes community with projects like Leader Workers Set coming in, really helping and pushing that boundary of what LLM workload can look like in a large-scale distributed environment. But Kubernetes management is complex. Like there's no two ways about it. Regardless of what your level of expertise is, when you try to mix this LLM workloads on top of Kubernetes, it can be challenging. It's really hard to figure out how to run this in a very high scale environments with hundreds and thousands of GPUs with distributed infrastructure for training and inference. You also, as an organization, have to figure out how to run this in a very secure fashion. So governance is a huge aspect that comes into play. You want to be able to make sure that the images that you're using in these Kubernetes environments are vetted by your platform teams and follow organizational standards. And then finally, when we talk about developers and MLEs and data scientists, they need a way for them to define these applications in a native API that they understand. And this is where technologies can really shine, because Ray provides you with these abstractions where it doesn't matter what your underlying compute substrate is. You interact with the Ray API, and Ray kind of abstracts all of the orchestration of those AML workloads for you. And so we ran an internal survey with some of our customers to figure out what are some of the challenges that customers are running into as they run these workloads on Kubernetes. And by far, the most important challenge that came out was the complexity of infrastructure management. Handling Kubernetes at a large scale, whether it's managing upgrades or managing AMI patching or figuring out the networking or figuring out how to expose these applications to the outside world is quite challenging if you're just starting out with your journey. And then you have to deal with high compute costs. GPUs are expensive, they're hard to come by. So you have to figure out how to maximize the utilization of this GPU usage across your enterprise. Maintaining control over these large-scale deployments across distributed deployments is also challenging for a lot of our customers. A lot of our customers run hundreds and thousands of clusters globally. And so how do you get a handle on what versions of Kubernetes am I running? How do I maintain compliance with respect to the versions of Kubernetes? Whether it's, am I entering into an extended support model where I'm paying extra for running older versions of Kubernetes? And we discussed the technology sprawl. The ecosystem is awesome, but at the same time, it comes with the cost of learning all these different tools and technologies that you have to maintain and manage on your own. So the question becomes, what if there was a way to take advantage of the Kubernetes ecosystem, but offload some of that undifferentiated heavy lifting to your cloud provider like AWS, right? And so we really think that EKS Auto Mode is going to be the way through which you can achieve that, where the shared responsibility model has now shifted, where previously, if you were to imagine a line where this is where the AWS responsibility is kind of in managing all of that Kubernetes infrastructure, and this is where you are with your workloads, that shared responsibility model has shifted above, right? So now with EKS Auto Mode, AWS takes the ownership of not only the control plane of the Kubernetes, but also the data plane of Kubernetes. So EKS as a service will manage not only the control plane, the data plane as well, the patching of the nodes, the networking, the storage, all of that is kind of a managed experience for you. So if you're familiar with something like Fargate, it is like a Fargate-esque experience, but with EKS, and it's 100% compliant with upstream Kubernetes. So the core capabilities that Auto Mode gives. Number one, it's easier to get started. It's a single-click deployment to deploy an EKS Auto Mode cluster. And then number two is it's basically you have access to pretty much all of the EC2 instances offering that we have to offer, whether it's ARM instances with Graviton, the GPU instances, with the Neuron instances, all of those can be used with Auto Mode. And with the different compute provisioning options, as whether you're purchasing spot capacity or on-demand capacity or using capacity block reservations to run those training jobs, all of those are possible with EKS Auto Mode. It's a fully managed control plane experience as well as data plane experience. So when it comes for time to upgrade, it is a single-click deployment of an upgrade process, and then the control plane upgrade kicks off, and eventually the data plane upgrade kicks in, and you just have to manage making sure that your applications are tolerant to these nodes going down for being replaced with the new upgraded nodes. It's secure by default. As I said, the shared responsibility model has shifted, right? So we are taking more of that responsibility of making sure that those nodes that we are provisioning for you with EKS Auto Mode are fully managed and patched by AWS. And yeah, like I said, it's 100% Kubernetes compliant. So you can run any Kubernetes workload, you bring it in, workloads like Ray or any other open source frameworks that you're running for your AML workloads, those are compliant with EKS Auto Mode. So when you think about what core capabilities it has with compute, storage, and networking, with compute, we automatically scale the compute for you. So behind the scenes, we are running a technology called Carpenter, which is basically our version of the cluster autoscaler. So when it sees that there is pod that need additional resources to be created with EC2, Carpenter will provision those EC2 instances for you on demand. And when those pods are terminated because of autoscaling, they're no longer needed, those instances are then taken down to save you that compute cost. We use a container optimized OS called BottleRocket. It's a highly optimized OS to run container workloads, and it provides a secure way of running your applications. It includes health monitoring and auto repair. So if you think about GPUs, they're notorious for hardware failures. They're very sensitive to temperature and other error correction codes. And so there is an agent that runs as a daemon set that monitors these GPUs. And if there is a failure, you have an option to replace or restart these instances and it automatically takes care of that for you. With respect to storage, the EBS driver is built into the Auto Mode cluster. So if you're using EBS for your storage, it's available as a managed CSI driver. You can use your EBS just as you would with persistent volumes and persistent volume claims, and EKS Auto Mode handles that. With respect to networking, it's one of the biggest challenges our customers run into is IP exhaustion, right? It's a big challenge that the custom organizations constantly run into with really large workloads. So having a managed experience to make sure that we are managing the networking for you, you don't have to worry about running out of IP addresses. It's a fully managed experience for load balancing as well. The load balancer controller is managed by Auto Mode. So when you have to expose your online inference application, you just specify the ingress class for this particular serving application. The load balancer controller that's running in the backend will provision the load balancer for you and configure that to expose your application. And same with DNS, the core DNS capability is fully managed as well. So here I have a array serve cluster that's running on EKS Auto Mode. Right now, in this demo, it's basically serving a VLLM that's hosting a Quen 0.5b parameter model. And you can see here with the VLLM configuration, it's a standard array LLM configuration. It's specifying an accelerator type with L4, which maps to the AWS G6 instance type. You'll also notice that we are providing a load format called Run AI Streamer. This is a plugin that's provided by NVIDIA through Run AI that helps you load faster, helps you load models faster into GPU memory. And this model is being loaded right now from S3. And keep in mind, we're using the CSI driver for S3, which means that we're mounting S3 as if it was a file system and mounting that file system into the pod and loading up that model from S3 into GPU memory. Right now, this cluster is kind of idle. It's not doing much. And so you can see here that VLLM is running through array serve. There's a head node with 3 worker nodes. These worker nodes are distributed across 3 different G6 instances. There is, and we can run a sample command to say if it's working. And so it's going to run a sample prompt. It's basically going to ask what is machine learning, and the model is going to respond back with its response. And so what's going to happen next is that I'm going to run a load test, and we're going to simulate real-world traffic, and we're going to try and upgrade the Kubernetes cluster from 1.33 to 1.34 while keeping this array serve cluster up and running so that we have 0 downtime upgrade on this array cluster. And so when we hit that single command, we see the spike in the request. So we're seeing that request go through, model response, and it's happening. So now the load test kicks off. And as soon as the load test gets kicked off, we're going to start seeing that traffic coming into the cluster. And as the traffic starts flowing in, it's going to basically go through that load balancer, hit the array head, and it's basically going to be distributed 33% to each worker node. And we see that spike in traffic. And so imagine this is a real-world application. You're serving your customers, your application is live, and now it's time to do the dreadful Kubernetes upgrade, right? It's a nightmare scenario for a lot of platform teams today that have to go through hundreds and thousands of these cluster upgrades every single annual cycle. So they come into the EKS console and they see that banner, that flashing on top. It's time to upgrade, otherwise you're going to enter that extended support mode, which costs extra. So how do I kind of make sure that my array serve application is always up and running while I do these upgrades? So I'm going to go ahead and click that upgrade button to kick off the upgrade. So when I hit that button, what's happening is EKS is going to first upgrade the control plane and eventually get to the data plane. And the way it gets to data plane is basically through Auto Mode. So we're going to make sure that the node pool configuration for Auto Mode is now pointing to a new AMI, right? It's going to point to, instead of 133, it's going to point to a 134 AMI. And we're using a mechanism called Carpenter drift. And this is basically a reconciliation loop that runs within Carpenter to make sure that what's showing on my EC2 instance matches what is in my node pool configuration. So you're doing a declarative upgrade process. And so as soon as that drift is detected, Carpenter will start creating these new node claims, which are basically used to provision newer instance types with the 1.34 AMI in it. And all of this is happening while your array serve is still getting hit by that load test, by your live production traffic. So eventually, what's going to happen is through use of Kubernetes native paradigms like pod disruption budgets and health checks, we have made sure that our array serve application is tolerant to these failures that are eventually going to happen with these array workers as they get drained out of the old instance types with the old version and get launched into the new instances with the 1.34 version of Kubernetes running. So it's going to do that through a mechanism called node disruption budgets, right? So just like we have a pod disruption budgets for pod, with Carpenter, you can specify a node disruption budget so that you're replacing only one node at a time and not going through the entire node at the same single batch. And so you're going to see these worker pods getting drained out of that old node and getting provisioned onto the new node that Carpenter has now provisioned for us. And these pods get relocated to that new node while the other two pods are still running on that old version before they get upgraded eventually. So this is kind of what that architecture looks like when we run RayServe on EKS Auto Mode. As you can notice in this diagram, I've not shown the add-ons that you would typically see in an EKS standard cluster, right? The VPC CNI, the core DNS, kubeproxy, load balancer controller, EBS CSI driver. All of those add-ons or core cluster capabilities are running behind the scenes in the EKS control plane. You as a customer are not responsible for making sure that those add-ons match the version of Kubernetes that you're running in your production environment. EKS will make sure that those add-ons are matched to the version that we're running today, and they'll make sure that these add-ons are upgraded as these clusters upgrade. So the key points that we want to take away from this architecture is that, let Auto Mode manage your Kubernetes cluster. EKS Auto Mode will manage these EKS add-ons for you. You make sure that when these upgrade cycles happen, and they happen twice a year at least, that you're ready for it, that you're not spending time as an MLE or as an ML platform team to not only manage your Ray clusters, but also your Kubernetes clusters. The Kubernetes clusters is, again, coming back to that shared responsibility model. EKS is taking care of of the Kubernetes part of the equation, and you as a customer are bringing your Ray workloads and running those Ray workloads on EKS. We are using pod disruption budgets to make sure that Kubernetes native mechanism exists to make sure that there is no disruption on these pods. We're executing graceful shutdown through the use of health checks, and we're doing sequential updates using this node disruption budgets. And with the use of the NLB with the AWS load balancer controller running behind the scenes, we're making sure that the traffic is seamlessly transitioned from the old nodes to the new nodes. Here are some resources that you can use to refer to what I've shown. The first one is the documentation for EKS Auto Mode itself. The second one is the GitHub sample repo that I've published, which basically can be used as a reference implementation. So if you're looking to, if you're trying to figure out how do I run my RayServe application on EKS, how can I run it in a production grade manner, I have a sample repo that I published on this repo. Use it as a reference. Feel free to create issues and PRs. If you have any improvements, I'm happy to take that feedback. And then finally, if you're new to EKS and want to kind of ramp up on EKS skills, we have a self-paced workshop that you can use. We can also run it in a team setting with your entire team. You let your AWS account team know, and we can run that workshop in an instructor-led fashion for you in your in AWS accounts, so that you're not spending time learning Kubernetes in your accounts. And lastly, that's my LinkedIn QR code. Feel free to reach out if you're running into issues as you run these AML workloads on Kubernetes. Our team is ready to help you out. Feel free to reach out to us. We also have a booth over there at the corner where you can come chat with us, come talk to us about your workloads that you're running on EKS. That's it. Thank you.